Okay, cool. We're rolling. Okay, hey, I'm Jacob. I've never done live streaming before, so this will be a fun experience. Today, I'm going to be doing some work on my game, tentatively called Prospector. It's a prospecting and survival game set in space, and I'm making it using the engine Game Maker Studio 2. So the reason why I'm doing a bit of a voiceover here, even though I don't see one in the room yet, is because I'm going to upload the recordings of my streams to my YouTube account, which is linked in my Twitch profile page, along with my Twitter account, to my game studio, which is called Loonwork Games. I'm participating in something called DevTober this month, which means every day this month I'm going to be posting some kind of update about my game, something that I worked on. And a bunch of other people are doing it too. So if you go to Twitter and you just do a search for the hashtag DevTober, you'll see a lot of really cool projects, really cool stuff that people are working on. If you want to get your hands on the latest version of a demo of my game, also on my profile page, you'll find a link to my Discord account. And one of the channels in there, I think it's just called Builds. I think I changed it to Demos. Yeah, it's just demos now. So if you go there, you can find, I promise is not a virus, zip file which has executable of my game. So right now I can only put stuff out in exe format based on my license with GameMaker. So if you don't have Windows or you don't have some way to run an exe file, you're kind of out of luck. Sorry about that. But if you do, you can go grab that version and play around with it. So today, what are we working on? Today, what I want to work on is I've been doing a lot of work for my game related to, I guess, a really big like thematic feature set called just like base defense. So one of the big cornerstones of the game is that you build this base on this alien planet and you're trying to gather all these resources because you're trying to strike it rich. But this planet is like very hostile. You'll get attacked by bugs. There's definitely like things in the environment that behave in a strange way, in a way that's kind of dangerous for you. I don't want to say too much right now because I'm not really working on all that stuff during this stream. But as kind of like a basic rule of thumb, you're not going to make it very far if you don't know how to kind of like protect the stuff that you're building for your base. So I wanted to play around with some different ideas for how that could work, like how base defense works. And I actually have some sketches here that I'd like to share. Let me go ahead and pull some up. Yeah, here we go. So I've got some ideas here. I was on a previous call with some friends, and we were kind of like talking through some of these ideas too. So it's not like I just worked on this morning. It's kind of been an in progress type thing. But we were exploring different ways that the player could kind of like protect their investment, I guess, so to speak. We came up with some different ideas, and I was trying to kind of like figure out which one I wanted to go ahead with before I came to the realization that it's probably better to put a variety of things in there and play test it and find out what people are liking. Um, and it might be the case that like having all of them in there in the game is fine because it gives players really interesting choices around kind of like how they want to do defense for their base. So at a high level, I'll kind of explain what these ideas are. There's basically like this concept that just let them build walls, which if you've played any kind of like tower defense game, it's like this idea that if you wanted to build a maze for things that were attacking your base, you could kind of like funnel them through different corridors and use that to kind of like design the layout of your base so you can figure out like basically how to snake them through a maze so they can take a lot of damage from your towers that you're building. The second one is this idea that maybe it's kind of like a combination of a platform and a wall. So the idea is that you can kind of go step on this platform and then like shoot over a wall. So if you're on the wall, you're shooting over it. If you're standing next to the wall, maybe you're repairing it instead. So it kind of has some nice flexibility there so that you have line of sight with enemies that are kind of like beyond your base, so you don't feel like you're trapped behind your walls. Um, Idea three was this idea that you could have like laser wires or like a laser fence. The idea on this one is that no matter what, like we could have a basic gate or like a movable part of the fence or something for the wall, which is necessary because like the player needs to be able to like come in and out of their base. But if we wanted to play around with this idea that maybe gates are a little bit more dynamic in the sense that you're not just like picking like do I want a vertical gate or a horizontal gate, and it's more like you could set up a grid of laser wires that the player can kind of like run back and forth across, but enemies like the bugs, they have to like attack the things creating the wires. Like they can't pass through them, so they're like denied entry, and then they've got to figure out like how to dismantle your laser wires. And then the fourth idea here is well, why don't we just like create some kind of guard tower? This one was kind of inspired by the guard towers that exist in like Age of Empires 2, or a lot of other games like RTSs where you kind of have this concept of like walls and barriers and then towers that like shoot over them. But in this example, the idea is that the player can hop into it. They can like shoot over the wall. Maybe they have like bonuses for being in that tower related to defense and attack, but they can't freely like move around the perimeter of their base. So they kind of become like a stationary turret, so to speak. So the idea that we're going to be working on today, and I did like a really really crude sketch of it here, is we're going to be playing around with the laser wires concept. I already put something really basic in for ideas one and two for like the walls and the platforms, so I'm going to show you that here in a second. But the laser fence is what we're going to be working on today. Okay, give me a second here. Yeah. Okay. Cool. Um, so why don't I go ahead and just run the game real quick, and we can take a look at it, so I can show you at least the walls and the platform stuff. Building, 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 building. Slow today. Okay. Um, so here's what I've got so far for this stuff. Obviously, these are walls. Hopefully that's obvious. All of the art is placeholder for a lot of this stuff right now. I'm just kind of like throwing in quick and dirty stuff to like figure out how the coding logic of this stuff needs to work. So with the walls, basically what's happening here is if I go into this is like the build catalog for the game. So if you've played any kind of like base building or crafting game, you're kind of familiar with this concept of like you have a catalog, and inside of it there's like different recipes or blueprints for things that you can do. So in here, I'm going to go to military. The categories are still TBD. I keep changing them, but I'm going to go to this simple barrier, which right now, like basically costs nothing. I haven't really wired in what everything costs in a way that like makes sense with you going out and collecting resources yet, because I'm just playing around with like which structures and barriers and stuff feel good for the experience. But let's go ahead and just build a wall. So you can see I've got this segment already exist, and the way the game works is that when you're in build mode, you can kind of like drop stuff wherever you want to put it. So I'm going to put this one here, and you can hear that snap, and what happened is this wall kind of like connected to that segment. So it's basically checking around it to be like, okay, are there other pieces of wall here, and then you can just kind of like build it out. So I'm going to put a couple more of those down. Looks like I've got a bug there that I'll have to fix later. But that's how walls work. And then for the platforms, what I've got right now is I kind of like wanted to see what it would feel like if I didn't combine the wall with the platform. So what I have right now is this idea of like you can build platforms behind the walls in certain places if you want an elevated kind of like line of sight. So you can run around behind here, and it's like elevating the player so that now instead of shooting and hitting the wall, you're shooting over the top of it. So that way you can kind of run around the perimeter if stuff's attacking you and kind of like take it out. And then you can jump down off of it so that now you're back on the ground, which means you're shooting into your walls, which would repair them. Actually, I don't know if that's actually true yet, but that's how it works. Um, then other stuff in here, I guess, while we're in here, so I can kind of explain it a little bit, is a big part of this game is going to be power distribution and management. So there are different things that the player can build from the catalog that generate power, and then there are structures that use power that the player can use to defend their base and to basically like process and refine resources that they're collecting on the planet. So the idea is that you start out and you have something really, really basic and crude, probably just like walls, maybe platforms, and maybe like a furnace or something. And nighttime comes and you get attacked by bugs and you like barely survive. And eventually, if you kind of like invest more in the resources and the blueprints and you get better stuff to defend yourself, you'll have a little bit easier of a time. You can like kind of grow your base and protect all your investments and stuff like that. And then the enemies will get harder too because hey, it needs to stay challenging. So that's what we've got built. And let's talk about the laser fence. So what we want to do right here in this gap is basically the player, like I was saying earlier, needs some way to go in and out of their base that also kind of like protects it so stuff can't come in. So if the player got attacked right now by a bunch of bugs, they would basically just march right in here and take everything out. And it'd be really hard for the player to keep up with like a huge wave of them, which is typically what happens at night. So we're gonna have to have something that kind of like closes this gap. If I build just a wall here, then the problem is pretty obvious, like I can't get back out, which means that I'm stuck behind the wall, and even with the platforms I can shoot over it, but I can't jump over the wall. So we're going to use the laser fence as a way to kind of like uh, cover that hole, so to speak. So let's go ahead and close this, and let's talk a little bit about how we might do this. So I'm going to bring up one of my sketches again. So the idea for this laser fence is I was starting to think about it just as like a traditional gate. So like the idea of a gate is that it's kind of like a special section of a wall that can be open or closed, whether it's toggleable or like something that auto toggles whenever the player is close to it. And what that means is that whenever the player goes to place that gate into the world, there's basically only two orientations, is what I call them, like build orientations. They can do it horizontally to connect like a horizontal section of wall, or they could do it vertically to connect a vertical section of wall. So nothing at an angle, but you could do like left, right, top, bottom, but really it's only like, is it vertical or is it horizontal? What I wanted to do with this laser fence is kind of like explore this idea that instead of it being like two posts that connect something in the middle or like one piece that kind of like comes up and down, I wanted to play around with this idea that it's kind of like a fence post that shoots out laser beams, and then the player can rotate it either north, south, east, or west. So you put this post in the ground, and then you specify kind of like which angle you want the fence to be pointing, and then you can basically from there build out as many segments of fence that you want. Um, and I think there's problems with that already conceptually, but I kind of wanted to play around with it because something about that seems interesting to me. And often what I'll do is I'll try to prototype something crudely and then just kind of like see how it feels and then adjust from there. So we may back this up and like just do a typical fence where it's kind of like what I was saying, the vertical versus horizontal alignment. But for now, let's go ahead and see if we can figure something out with this. So the first thing we're going to have to do is we're going to have to think about how this is going to work with enemy pathfinding and collisions in the game. So if I go back to kind of like my overworld design here, um, basically the way the enemies work is that they're trying to find using something called the A-star algorithm to figure out the closest, or sorry, the shortest path from where they're at to the player. So the player is always their target, at least for now. If the player is behind something that has an obstacle between the enemy and the player, basically the pathfinding is going to be like there's no path. I can't get there. And what we want to do in that instance is we want to say, okay, if I do like a collision check between this bug and this player, like what are all the things that are getting in the way of me attacking my target because I'm the bug, and how can I like target that instead and destroy it? So the idea is that the bugs are going to be able to chew holes through your walls. They're going to be able to attack your fence posts. They're going to be able to attack your buildings. They're going to be able to attack your turrets. Um, so they're somewhat intelligent in the sense that if there's a hole, they're just going to attack from that angle because it's the path of least resistance. But if there's something in the way or there's something causing them damage, meaning that it's aggroing them, then they're going to attack that instead. So why does all that matter? Well, it matters because with our fence, with our fence, it's not just the post that needs to be an obstacle. It's like the laser that gets created. So we have to figure out how we can know basically which sections of this grid are places where the enemy can't walk, and then use that to determine what thing they want to attack to make a hole so they can get to the player. And when I mean grid, like you can literally see it here, this whole game is designed and built on a 32 by 32 pixel grid, um, which in really basic terms just means that a lot of the kind of like uh, a lot of the logic around like where you can build things and where resources are placed and how things move is not based on like a pixel by pixel perfect system. It's kind of based on this idea that things inhabit general spaces um, on a grid, which helps kind of like have everything have like a cohesive look and feel. It helps scaling out like different kinds of objects so that you've got like some semblance of like proportional scale, and it also just reduces a lot of the complexity with coding a game like this because then you can basically not have to like check exact positions of everything in the room at all the time. Like the way that all these resources populate in the world is kind of like a combination of procedural generation and manual like placement or like manual level design. And they're locking into these grid cells and saying like, hey, I occupy these cells, which basically lets me know like whether there's something in the way. So it's not like when the enemy's trying to move, they're not checking to see if this particular spot is free. They're checking to see if there's this grid cell is available, which in this case it is because the collision of the space is down here, so they can walk behind it because this is free, this is free, this is free, this is free, this is filled, this is filled. Long explanation, but that's kind of what I mean when I say the thing's built on a grid, which means our solution has to be grid based too. So I think what we're going to do to start is I'm going to create a new object, and let's call this obj laser fence. We'll make a sprite here in a second, but it's definitely going to have a create event, and it's definitely going to have a step event. Um, that might be all it needs for right now. So what is this stuff? Um, Basically, the way this works is GameMaker runs on this concept of you have objects, and then those objects have like different lines of code that they run every frame or step of the game. So when I say that I'm making this create event and this step event, what that means is that whenever the objects are placed in the room, when they're first created, like we're going to do all the stuff that I'm about to write in here. And then for every frame of the game, while the game is running, they're going to run code top to bottom for everything that's in this event, this step event. So starting with the create event, one of the things we're going to do for now is we're going to ignore the fact that laser fences are probably going to need to be connected to the power grid because I don't want to like debug all that stuff right off the bat. I just want to get the basic concept in where it's like a thing that the player can walk up to and toggle like which direction the laser is pointing. Um, so for the create event, we're going to have some setup here, and typically the orientation of sprites is in the top left corner, meaning that whenever we're checking to see where something's at, if it was like something that was like, uh, two grid cells tall and one grid cell wide, the place where it's actually going to be placed in the room is like the top left corner of that. And because of that, if we're trying to figure out where the center of something is, we need to do some really basic math here. So I'm going to say center x equals x plus sprite width divided by 2. And center y equals y plus sprite height divided by 2. So that'll give us like the middle point of however big this sprite ends up being, which right now this means nothing because we haven't made a sprite yet, but later we'll see why that's important. Um, what kinds of other things do we need to do here? We need to... Actually, this doesn't make sense that I'm creating it as a new object because it should be a child of the parent object. So I'm actually going to delete this. But it's good for me to kind of explain like the two events that we're going to be working with today. And I'm actually going to make a copy of um, this entry. And I'm going to say obj laser fence. So this is an object that already exists with a lot of in the create event. We've got all this stuff. So we're going to need to update all this. So we can take this stuff out. We can take this out. Is interactive is true. And I'll show what that means here in a second. It's not going to have a sound. It is going to occupy a position in our grid based on all this stuff I was talking about earlier. It's not going to start built. Actually, for testing purposes, I think it is going to start built. I don't think we're going to ask the player to print it. Makes or uses power is true. Is powered is going to start false. Makes oxygen is false. Energy usage is, we'll just say -1 for now. So it's going to take 1 power to power this gate. Depth equals -b box bottom. Yeah, all this stuff. All this stuff seems fine. Yeah. And we don't need this. So let's go over to the destroy event and see if there's anything in there we would want to change. No, this all looks fine. So what is the destroy event? The destroy event, at least in GameMaker, what that means is that whenever an object is destroyed, like let's say it's the enemy attacks a bug and their HP goes to 0 and then they do some kind of exploding death animation and then they disappear. What we can tell that object to do, at least in GameMaker, is, oh, if you're about to remove yourself from the game, like do all this stuff on your way out the door, so to speak. So this is playing a sound because right now we're talking about a structure, so it's playing like a demo, like structure explodey sound. It's doing this thing where it's telling our power grid to reroute power which I won't get into that right now, but that's kind of what that's doing. Um, and then we have a custom script here that says, hey, remove this thing from the grid so that like things know they can walk there again. So we're going to leave all that the same. That's fine. End step event is fine. That's how we add it to the grid. Draw event. Draw event. Should stay the same. The step event is where things will change. So I'm going to go ahead and blow this up really, really big. Um, just so we can kind of like see what we're doing here. Actually, no. Something like that. So in here, one of the things we're doing is we're checking to see if this thing is built. We're checking to see if it's powered, which we still want to do. It won't have a target, so we'll take all this stuff out. Um, we can take all this stuff out too. So how do we want this to work? What we're going to do is over here in the create event, because going back to our sketch, um, we want the player to be able to rotate this thing. So the way we're going to do that is I'm actually going to come in here and I'm going to give it a default like direction that it's pointing. So I'm going to say cdir, which stands for current direction. I can't just say direction, which would be easier to understand because that's a built-in game maker like name, which means that it has like special code and stuff that happens when I use that name. So I'm not going to use that. I'm going to come up with my own, and I'm going to start with 0. And the reason why I'm doing 0 is because if you're talking about image angles or degrees of rotation, 0 in GameMaker is straight to the right. And I won't get into the specifics on that, but basically what that means is um, a lot of how this works is it's based on a default positioning of things pointing to the right, like all the art and designs and stuff. So we'll just go ahead and stick with that convention. And then over here in the step event, what we're going to do is check we're going to check to see if the player is walking up to this thing, and we're going to check to see if they're trying to rotate it. So if it's built, if the thing is built, and if it has power, then the player should be able to interact with it. A little bit of a comment there. So how do we do that? Well, there's a few things we have to do. We're going to say if key primary press and press buffer equals 0. So what does this mean? I key primary press is basically I have a script that basically stores all the like key bindings and stuff for the game. So right now the primary interaction key in the game is the F key, which is right next to like your movement keys if you're using WASD. And what this is doing is it's saying, did the player press the interaction key on the keyboard, and is the press buffer 0? What does that mean? Press buffer 0 is something that we're going to have to define, and the reason that we're going to have to define it is because, like I was talking about earlier, the game executes on frames. And whenever you hear something like frames per second, that's basically what they're talking about, which means that everything that we put in here, because this game is set to run at 60 frames per second, this is gonna run this. It's gonna run this script 60 times for every real world second, which is like really fast because computers think really fast. Um, And because of that, that means that there will be multiple frames where this is registering true. So to prevent a scenario where the player presses F and the thing rotates like 5 or 6 times, because like it's covering multiple frames, we're going to put in a buffer. So how do buffers work? The way I do them is like this. I'm actually going to make a new set. Oh, actually, I'm going to put it down here in interactions. So I'm going to say um, press buffer. Move this over here. Uh, press buffer max equals, and it doesn't need to be very, very long. We're just trying to make sure that they don't like do the same action multiple times by pressing the key once. So we'll play around with this. I think 4 will probably work. And then I'll say press buffer equals press buffer max. What that's doing is it's defining the max value for this buffer, and then it's setting the current buffer to the max, which means over here what we're going to need to do is um, when that interaction key is pressed, we're going to change the buffer to be 0. And then for every frame, we're going to count up on that buffer until it reaches the max. So that's whenever we know that the player can like rotate this fence again. So here I'm going to say when, sorry, increase pressed buffer every frame of game. And the way we're going to do that is we're going to use a function that I wrote called approach, which is based on another tutorial from a really long time ago. But we're going to say press okay, press buffer um, equals approach press buffer press buffer max 1. Yeah. So every step of the game, we're going to get closer to this max value. And once press buffer equals press buffer max, we'll reset it. But we're actually not going to reset it here. We're going to reset it after the key is pressed. So basically, this buffer will build up, and then down here we're going to check the player's trying to do something. They're pressing the F key. If the press buffer equals, this should be press buffer max because we're counting up, not down. Then let player rotate fence, and then reset buffer. Down here for reset buffer, what we'll say, just so we don't forget to do this, is we'll say press buffer equals 0. So we let them rotate the fence. We set press buffer to 0. So that way when it comes back through here, this is going to go from 0 to 1. Press buffer does not yet equal press buffer max, so we won't let them rotate it until this fills up, and then they can do this again and reset it. So now we can talk about rotation. So how we're going to rotate this thing? Well, we said that the rotation is going to start at 0. So every time, I think this will work. I could be wrong. But I think it's going to be as simple as adding 90. Because if you think about a circle with degrees, basically we want the player to be able to point this thing in cardinal directions north, south, east, and west. And it's starting out pointing east. So if we add 90, it's going to go from west to north. Another 90 will take us from north to west, and then another 90 will take us from west to south, and then another 90 will take us from south back to east. That should work in theory, but we'll find out. So we're going to let them rotate the fence. If they press this button, then what that means is cdir plus equals 90. And I'm using a magic number here, which is fine. I'm going to ignore that for now because I can always come back if this works and make that a variable instead of a magic number. Um, and that should be all it is in the step event, at least for now. So, okay, well that's rotating, but like we still don't have a sprite for this thing, and we still don't have a sprite for how the lasers are drawn. So over here in the draw event, what we're going to look at, and this is still based on the old code for the sentry turret. So we're going to have to replace this because we won't have a target like this, and we won't have anything like that. So we're just going to inherit the event from the parent object, and then we're going to do something different here. So what we're going to do is we're going to draw a line in the direction the fence is pointing. So how is this going to work? Well, if we're thinking about what a what the laser is it's a line, which means that a line has an origin coordinate in the room and it has like a destination in the room. So in order to figure out where that line needs to be drawn, we're going to use a built-in game maker function to kind of like figure out where the start and end point is, and then like draw a connection between the two. So we're going to say draw line width. And the first thing it's going to ask us is it's going to ask us like where are you starting to draw this from. So if I go back to my create event, because this is a stationary object that does not move, we're going to use, I think we should just use the center X and center Y and not use this offset thing. Yeah, let's do that. So we'll say center X equals sprite width divided by 2, center Y equals sprite height divided by 2, and fix your typos. So we'll draw it from the center. And to make this easy, I think we'll make it a 32 by 32 so we don't have to deal with like variable heights. But we'll say center X and center Y. And then for the X2 and the Y2, what we need to do is figure out, based on the direction that this thing is pointing, which way it needs to go. So we're going to have to do some math here. Var x1 and, whoop, that's not what I wanted to do. Var x1, var x2. And we're going to use a function called length dir x and make sure that we put in our center x plus length dir x. For now, we'll just hardwire the length to 64, which is 2 cells high or 2 cells wide on our 32 pixel grid. And then we'll say cdir. And then we'll do the same thing down here, which this should not be x2, this should be y2, and this should be x2. Center y plus, let's just copy this. We will need to change the function here so that it's length dir y. Okay, so what's that doing? What this is doing is it's saying in order to find these next locations that we need to draw this line, it's asking for x2 and y2. So draw a dot here, then draw a dot here, then connect those two dots is basically how this line will work when it's finished. This is how we figure out where the second dot is at. We say start from where center X is, and then in the direction that the fence is currently pointing, figure out the X and Y coordinates based on how far that line is meant to travel, which right now we're hardwiring to 64. So this is finding in the room where the point should be if the line is drawn in a particular direction at a particular distance. And then because we're using a draw line width, it's going to ask us how wide we want the line to be. So I'll just say 2. And actually, I want this to be a color too. So I think this is a thing. Yeah, it is. So we can do it with a width and a color. So for the width, we'll do 2, and then for the color, I'm actually just going to put a trash thing in here that I'll delete later, but I'll say C equals global dot color yellow, which I think is a color I've defined. If I haven't defined this, then that'll throw an error. Um, so we'll do same color twice. GameMaker lets you kind of like specify if you wanted the start of a line to be a different color than the end point, at which point it would like create a gradient between the two things. But we just want one solid line, which is why we have to put the same color in there twice. And I think that's it for this function. So I didn't really explain the draw event. What's happening here is that the way GameMaker works is that you've got this particular event type called a step event, which what I was saying earlier is basically like running every frame to see if the player is pressing this button. If the buffer's up, then they'll add 90 degrees to the angle and then reset. You can't actually draw anything to the game screen like what the player can see in this event. This is just for like doing like math and like logic stuff. In the draw event, that's where like the magic actually happens, where we're like drawing stuff to the screen. So there's some really basic stuff in here in the parent object where it's basically like telling all structures how they're supposed to be drawn, which I'm actually going to move up here. And we're adding this special line of code for this special object, which is a fence, where we're drawing this line to the screen after we've drawn the fence. So we draw the fence, all that stuff happens here, all the special stuff about how interactions work in the game, and then we'll draw a line in the direction that it should be pointing. So at this point, theoretically, we should be able to put this fence in the room and it should draw something. Actually, that's a lie because it still doesn't have a sprite. So we'll make a really quick and dirty like prototype sprite real quick, and we'll just keep it this whatever name. Change the size of it to a 32 by 32. Go ahead and hit apply. And then we'll go ahead and edit the image. I'm going to, let's just make it this bright blue. It doesn't matter. We're not going to mess around with art right now because that kind of just like gets in the way. Eventually, we may want it to look something like this. Kind of like the way that I split my work here, just to do a little bit of an overview as to like why I don't care what the sprite looks like, is because when I'm working on new features for my game, I don't necessarily know if they're things that I want to keep around for a long time or even like if they work at all. So typically what I do is I have an idea and I'll do the prototyping of it in code like what we're doing right now. And then if the idea was born out of like something visual, I may actually kind of like spend some time to design like what that thing might look like. So this is what our laser fences could look like. But ultimately the art is impacted by the programming and the programming is impacted by the art. So it's this idea that I can start here on a like a design tool, like a painter's canvas, or I can start with code with an idea. Like I kind of go back and forth between the two. This particular idea was born out of an idea that was like playing around with art stuff. Um, and now I'm trying to figure out how to code it in a really cheap way where I can figure out if it feels right. And then if it does feel right and I want to keep it in the game, I may come back and make it look more like this. But for now, it's just a, it's just a blue square, and that's all it needs to be. Um, okay, so now it's got a sprite. Now this thing should work. So let's go ahead and go back over to our world. And I don't really care about like connecting this to the wall quite yet. We just want to test to make sure that like this fence will work and the player can walk up to it and move it around, which I know there's one big thing about how this works right now, which will break this. Um, and I'll fix that when we get to that. Um, and because this thing does need power, we're going to have to connect it to the grid here. But I'm getting stuck. Oh, I keep selecting the biome. Um, Here we go. We're just going to extend these power tiles out here. So power tiles are how the player routes power throughout their base, and they're all connected to these things that generate power. This is like the big starting power structure. Um, yeah. So anything that requires power in this game has to be built on top of a power tile, which includes this fence. So in order for this to work, based on all the parent logic that this child is inheriting, it's going to have to be on top of this tile or it won't do anything. In theory, it might not do anything yet either, but we're about to find out. Oh, and I definitely said I was going to play some music. Unable to find it. Okay, we've got an error here. I'm going to move this over to another window so I can read this. Okay, abort. So we've got to figure this out. What it's saying is it's unable to find an instance for object index -4 on the controller step 0, line 81. All right, let's check that out. Oh, no. Huh. I must have a typo. So where is this happening? It's happening in the step event, I think. Line 81. Yeah, so it's saying here that there's an object that this grid is trying to route power to that doesn't exist. Center tile dot sources. Dot tile grid. Okay, well, is this saying that this doesn't even... We're going to do some debugging here. I just looked for a tile under this structure and found plus string center tile. I think what's happening here is that it's not actually finding the tile. Like it's finding the fence, but it's not finding the power tile underneath it to say if it has power or not. If we can't fix this very quickly, I'm going to kind of like bypass it and say that the structure always has power and don't connect it to the grid. I don't want to get mired here. Yeah, we'll check our debugging window. Yeah, I just looked for a tile under this structure and found -4. So it's saying that it looked in this position and didn't find anything. Oh, I think something weird happened here where the collision mask got shrunk into oblivion. Whoa. I don't know how that happened. That's interesting. Must have been something to do with like how I resized the sprite. Let's hit it again. I'm not sure if that's the case. It actually doesn't seem like that would be. Yeah, that wasn't it. All right. Hmm. Well, I said I wasn't going to get mired by this, but this is important. We need to figure this out because it may be there's an underlying issue with how this is working. That's gonna. I don't want to build a bunch of stuff on top of that. So there's definitely something there, tile wise. That's definitely there. So if I just move this off, I should get the exact same error. If I don't, that's going to tell me something. Yep. Okay. So it's got nothing to do with the tile. The tile's working correctly. There's something about like it's not getting added to the grid or something. And I'm going to think about that and come right back. Um, Sometimes it helps me to walk and come back. So I'm going to go ahead and hit pause here, and it doesn't look like anybody's in here except. Oh, it's like spam. Yeah, there's no one in here but spam. So I'm going to go ahead and say, I'll be right back. Okay, we're back. I'm just going to ignore this for now. And what we're going to do to ignore it is we're going to come in here and say is powered is true. Oh, actually, that's not going to work. I think we do have to figure this out based on how we want to do this. Hmm. Okay. We've got this sprite. It's positioned correctly in the room on top of a tile. So it's coming here when our grid object is trying to tell all structures if they don't generate power and they're not a battery, if they're built and not a wall, find the center tile. Center X and center Y. I wonder if because it's an exact 32 by 32, if that's causing a problem. So what we're going to do is we're going to say plus cell size divided by 2. I feel like I'm over explaining things, so I'm going to just do more work here. Let's see if that fixes it. Same issue. I wonder if it's because of the is built thing. Yeah. I'm thinking that might be it. Let's say is built is false. Doesn't generate power. Is powered is false. Interactive is true. Oh, I think maybe, hold on a second. It's got no offset. Okay, there we go. Ooh, that's loud. Okay, now we've got a new bug to contend with. But that's good, we're making progress. This is what progress looks like. Unable to find instant. Oh no, that's still the same problem. It's -4. Hmm. I think we're going to need to debug something here. Let's, for a second, let's not do this, and let's go into our mouse debugger. Okay, where's the one where we're checking power tiles? Oh, whoops. Okay, what's going on with this thing? Huh, none of these are returning anything. That might be part of the problem right there. So at least have one source. So that is working. Okay, let's turn all that off again. Let's come back over here. Hmm. What would happen if I just change the height on this thing? Oh, whoops, I didn't mean to do that. Same issue. Let's narrow this down. You're all doing it. Interesting. What the hell? What the hell? What the hell? Hmm. So this whole script doesn't work anymore. Are these things not appropriately being added to the grid anymore? See, obj tile. Where do I actually make that grid? Do I make it in here? I do. All of these say none. Okay, find all the places where you interact with global dot tile grid. The issue has to be there somewhere. We'll just go one at a time. So when you make them, you put them in the grid. When you destroy them, you remove them from the grid. When you create the grid, you make it for every cell based on the number of columns and rows in the room. You default them all to say none. You destroy the grid when you end the game. This is where you're doing the check and it's coming back -4, meaning it's not finding any tiles. This is where you're checking for a power tile. This is also where you're checking for a power tile. You're not updating it, you're just reading. That's where you route it in your script. That's how you expand the frontier of tiles. And that's it. And you know it's in there because you use the mouse debugger to find that tile and find its sources. So you know all that is working. So what seems to be the issue here? Let's go back into the controller. Make this bigger. Um, well, this is doing nothing. But it used to work. So something changed. Something changed with how this works. don't think there's anything different there. So why when I run this, is it not finding a tile? Wait, what the hell? Okay, that is strange. I don't know what I did. Okay. Honestly, don't know what I did. Well, let's go with it. Weird. So weird. Okay, print everything. Figure out what's going on here. Okay. Everything works. But not you. So what's different? Let's open up obj. Um, let's open up the sentry and compare it to our fence. So here we've got the fence. Let's check the create events. Event inherited. I think I just figured it out. Oh man. That is one stupid bug. Yeah, okay. Alright. Jeez. So I didn't have X and Y in finding the center location, so it was looking like some random place in the room to figure out where the tile was at. Why for a minute that broke all the other structures, I have no idea. But here we go. Laser coming out of the right. But we can't interact with it, and we know why. The problem is because of the parent-child setup here. Because none of our interactions actually work right now. So what we're going to have to figure out is we're going to open up obj player. Where would this be? The player suit. Let's find the place where we look for the closest interaction. That's where we check for platforms, check for interactions. It's looking for obj interactions parent, which is a child of obj light. Why do you even need... Is the player ever going to interact with something that's not a structure? Yeah, definitely. That's definitely going to be a thing. So you can't just swap out this interaction parent object with structures because you know eventually that'll break. So it's not actually solving the problem. The problem is that we've got this container of things that are interactive, which includes structures, and it might include like other objects in the room. So the way we need to set up is that your child is actually obj structures parent. Now I bet that's going to break all of our lights, but let's find out. Have to wait for it to get dark. No, actually it didn't. Okay. Did it fix the interactions though? That's the big question. It did. Okay, one step closer. Now we're into actually debugging our fence, which has taken us a while to get here. My apologies, but we're here now. So, it doesn't like... Oh, right. Because all of the interaction object right now is set up so that structures can print a menu to the screen, but this won't have a menu. So what we need to do is we need to actually... This is going to be confusing. I think this is definitely a flaw in how we thought about this from the onset. Is interactive is actually going to have to be false. Or what you can do is you can say is interactive is true, and then in the parent object, obj structures parent, in the step event, let's look for this. And has menu, which will have to be a new variable we define. So over here, is interactive, can interact, has menu equals true. We'll just, we'll say has menu equals false. And then which structures, if we just go into the structures here, which ones actually have a menu? Um, the muffle furnace and the laser workbench. So let's open this up. We're going to need to fix you to say is interactive is true and has menu equals true. Is interactive is true and has menu equals true. Okay. Oops. Okay. Now over here, or sorry, back in the parent, what we can do is this. We can fork this. So we're going to check to see if it's the closest interaction. And then what we're going to do is we're going to see if has menu equals true and resources added equals false. So we'll take this out here. So all this is doing now is it's checking to see if this object is the closest interaction to the player. And then from here, what we need to do is we need to say, if you have a menu and you haven't added resources, then you can do this, which will print a menu, which this structure won't do. Then we'll do if has menu equals false and can rotate equals true. Yep. Take this laser fence. Yep. Copy all of this. We're going to put all this in the parent. And then in the parent object, we'll have something here for rotating objects. Can rotate equals false by default, and then C dir equals 0 by default. Which means over here in the laser fence, in the create event, we're going to say can rotate equals true and C dir equals 0. So we'll keep all that together because those are, well, actually, we don't actually need to override that. We'll just stick with that so it can rotate. And over here, we're going to say we're not going to do this way anymore, but we're going to have to add our buffer stuff to the parent object. So where's my parent? Okay, here's my parent. Put that in. Now over here, boo, 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 boo. I can get rid of this. I just need to know if it can rotate. Now all I need to know is if this thing can rotate. Okay. Okay. Oh, and has menu needs to be false, which it is by default. So I think you're good. Yep, there we go. There's a laser fence that the player can rotate. That they can't walk. Now the question becomes, how tall do we want this thing to be? I think with these walls, they look kind of low. But I think it would make sense if we saw bugs attacking this. So I think it would look weird if it was taller than the walls. So I think we actually do want this to be a 32 by 32. So even though this is just whatever art right now, we're gonna do that. And be sure oh yeah, we messed up our collision mask. Okay, that shouldn't break anything. Oh, actually it will, because now it's moved up in the room. Okay. It works. Now here's the next question, is if we want this to be wide like that, that seems fine. But there's no way that the enemy's gonna know that they can't walk through this. And there's no way for us to stop the laser if the player is standing in front of it. So what I would maybe do, how do we want to do this? We can have it so that this object creates invisible objects in the places where it's rotated that can check for collisions. And if either of them, see at that point you should really just draw it like a laser beam. Literally one section at a time. But then if you've got a bunch of these gates, that's going to start to get really expensive. I think that works really well for the player's laser, But that's only one. If we set it up so that they had like 200 laser fences and they were all doing that really expensive check, I think that would kill our game's performance. So we're gonna have to think about how to do this in a different way. Yeah, we're gonna have to think about how we want to do this. At this point, I'm starting to wonder if it's even worth all the hassle to do this whole like rotation thing when they could just be like more traditional physical gates. Because what is that like? What is that actually giving the player in the experience? Well, like they can change the orientation of them on the fly, but they could also, I mean, they could also just turn it off, demo it, and put it somewhere else. We could have it set up so that they can place it in the room and then decide whether they want it to be what direction they want it to point. But I think that would be confusing because that would definitely be confusing. Hmm. So, and at this point, they're all looking for power too. At that point, it's just starting to feel like they should just be a fixed width or a fixed height, and then you're printing either a horizontal one or a vertical one. I think that makes more sense. Yeah, I think it does. You could still have it as one sprite, and then you'll just say like, did they print? Well, no, at that point that would be confusing in the catalog because it'd be the same object. Unless you created a laser fence parent, they print the parent. Oh no, it's that they print the child, and then the only thing that's different in the child is it like tells you whether it's pointing which direction it's pointing. Yeah. So at that point, it might actually make more sense that this thing is just it needs power and it has to be built on top of all that stuff. Okay. Yeah, I think that makes more sense. I think we're making this way more complicated than it needs to be. So how do we want to do this? Um, I think the way we want to do it, need to draw this. I think we want the player to have at least two grid cells. We want to have at least two cells of space for them to move through because they are a 32 by 32, so it's going to feel a little awkward having them try to move between two posts that are only separated by one cell. Which means that in order to print these fences, you're going to need to do a check for one height with four width or four width with one height, which means the sprite should be designed as a 4 by 1 or a 1 by 4, like that, or like this. Yeah. So let's go ahead and just design that then. So really, this whole can rotate thing kind of doesn't make sense. Because what we want to have instead is we want to say obj laser fence we'll call this obj laser fence parent. And then in the step event, if is built is true and is powered equals true, I think you're actually going to take all this out. And over in the player object, obj player suit, we're just going to do a check for a gate interaction. And the lasers are going to be on or they're going to be off depending on whether the player is colliding with them. Where do we want that block to go? Oops, sorry. Um, check for interactions. Check for laser gates. If place meeting x, y, obj, laser, gate, parent. Oh, sorry, laser fence. So check to see player is colliding with a fence. If they are, find the instance ID. So we know we're running into it, but not which one. So what we're going to do is we're going to say var colliding fence equals instance position x, y, obj laser fence parent. If call fence does not equal none, which it shouldn't ever equal none, but you never know, so it's good to put checks in there. Call fence dot on equals false. You do a check for all of them. No, I don't like that. What I would do is I would do a check in the fence. If it's turned off and it has power, then check until it's null. Yeah, okay. Yeah, so now back over in the laser fence, which I think, yeah, we're going to add a variable here that says on equals true. It'll be true by default. And then over here in the step event, if the player has turned this fence off, but if the fence has power, but the player is turning it off to pass through, then keep checking to see if the player is still colliding. Otherwise, turn the fence back on. If on equals false, if not place meeting x, y, obj player suit, on equals true. So that way the fence will only do this if the player has disabled it. So it's turned off and then it's like, okay, waiting for the player to leave. And then once the player is gone, we'll turn the fence back on. Yep, that sounds good. And now for the art on this thing, I think really what we're going to do is we're going to have two different sprites for each child type. And then they'll just use different sprite sheets. It's probably the easiest way to think about this. What does that mean? Well, it means at this point, you might as well just work in the higher fidelity. Yeah, let's work in higher fidelity. So we're going to cut a couple different versions of this fence. We need four images, because we'll have two orientations. It'll either be vertical or horizontal, and then each vertical and horizontal needs to be either on or off. So what we're going to do in our sprite sheet, did I grab that correctly? I don't think I did. Oh no, you did. Um, yeah, let's just grab. Whoa, interesting. Is that on the wrong layer? Huh, strange. Um, just give me this. Yeah, I just want this. Um, let's move it over here, out of the way. Actually, I'll make a copy of it. And we just had this comment about how that kind of didn't feel right because it was tall, but I don't know. I think it's fine that it's tall. Like if you made this a 32 by 32, what would that look like? Because you'd really have to like cut this down. Yeah, it would just be so short. I mean, you could like try to make it like this. That's actually not bad. Yeah, that's actually not bad. Okay, we'll go with that. Um, and we said we wanted at least, oops, we wanted at least two in between. There's one, two, and then we'd put it there. At this point, let's just make file, new. Wait, somehow I moved those tiles. That's weird. Now it's with. Oops, sorry, width, not height. Okay. This will be the on version. How'd you do it over here? I think it was. It's coming out of the side, but it's too wide and it's on the top part. Yeah, like this. Oh, whoops. You're drawing the line the wrong way. Like that. Yeah, that ain't bad. Okay. Let's go ahead and take this whole thing and move it up. Because now we need the um, horizontal version. So optically, this is always going to look strange because let's turn our grid on here so we can see it. Oh, these are a little offset. Let's actually fix that real quick so we can actually see the problem here. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. They would actually have bases on them too, I think. I think this whole thing would have a base to it. Not necessarily. I think if it's going to behave like everything else, it probably should. Yeah, so it should definitely have like something in the middle here. Let's grab the tile layer real quick and just grab us a tile. Doesn't matter. Um, does that look right? Yeah, I think so. If anything, what would you do? Would you move it down one? I think it actually looks better like that. Yeah, that's good. So if this plugs into the tile and it like sits on top like that, then what do you want this base to look like? Because you're kind of going to just like draw something across, I think. So what you might want to do is just take this color. Let's go with 4. So we definitely don't like that. Yeah, we want it on structures. There we go. Let's just make some kind of like connecting looking deal underneath. It can be really thin. And the color of it would actually be the brighter color, I would think. And then you can, because the player can walk over it, you can use a lighter shade of gray for the border. I think maybe you'd want to put a line like down the middle of it. But I think you actually want, um, yeah, maybe like this. Let's go with that. And then let's grab this slightly darker color for more contrast here. It's getting better, but I think it's too dark. Yeah, I think it's too dark. Make that a little bit lighter. Oh, I think you kind of need the contrast there. And what you're basically saying is it would have tiles all underneath it. Like that. So it would kind of sit over the top. Then if you wanted to put a beam there and there, you probably could. For this color though, like I think that's off. Maybe let's go with let's go with an orange. Like that maybe. Oh, you actually need three images because you need on, off, and unpowered. But that actually takes me over the time I wanted to stream today. So I didn't get super far into this idea, and I definitely backpedaled on it to do something a little bit more traditional. We got stuck on that bug for a while, but that's kind of how it goes sometimes. So I think I'm going to keep working on this today, and by the next time I do this, this will definitely be done, and I'll have moved on to other things. Um, and this was kind of like a trial run, and I didn't properly tell people when this was happening, so I'm not surprised that no one showed up. And also the time is kind of strange. So some stuff to think about. I think that in the future, what I'll do with these is I'll be a little bit less talkative, and just kind of do more work. Just so I'm kind of documenting things as I'm making them. And then occasionally, if I need to think out loud, I'll think out loud. Um, but I will upload this to YouTube. So if you're watching this on YouTube and miraculously you watched all the way through, which would be very surprising, um, then you could see more updates on my Twitter account, which is, again, like I said at the beginning of the video, it's all my links are linked to my Twitch profile, but you've got um, my Twitter account, Loonworks Games, um, and you've got my link to my Discord if you want to get a build of the game. And hopefully the next time I do a build, it will include this and also the walls and the platforms. So that's it, and I'm going to sign off. Thanks, bye bye.